Okay, so this is the second video for 1.1. Today we're going to cover the transformations of parent functions, what we can do to them to make them different equations. So we're starting here. Transformation changes the size, shape, position, or orientation of a graph. So under transformations, we have translation, which just means we're going to slide the graph. We either slide it left or right, or up or down. So we're going to shift it horizontally or vertically. But it does not change its size, shape, or orientation. Another transformation we cover is reflection, means we flip it. It's a transformation that flips a graph over a line called the line of reflection. And another transformation that we'll do is either vertically stretch or shrink the graph. So it multiplies all the y-coordinates of the same positive factor. So it'll be a factor other than 1, obviously. If you have a slope of 1, it means it's not stretching or shrinking. That's the parent function does that. The reflection is where if the vertical stretch or shrink is negative, that actually is the reflection piece, and that's why a vertical stretch or shrink is a positive factor, okay? It stretches if that number is greater than 1. It shrinks it if it is between 0 and 1, okay? So, we'll just move right over here to the next page of the notes. So if I want to graph this graph and its parent function and describe the transformations. So I'm going to graph the parent function in black. I look, this is a linear equation. Okay, so my parent function is a straight line, goes through 0, 0 with the slope of 1. There's the parent function. And then this equation, now back when you graphed lines before, remember it's y equals mx plus b. B is that y-intercept, so we're going to graph that first, and that's -4. And our slope is what's in front of x. In this case, it's 1, which is the same as our parent function. I know it's not perfect. It's really hard to graph on this, but all right, we're going to say that's good enough, okay? So I graphed them both, and it wants me to describe the transformations. So if I look at this parent function, they both have a slope of 1, so the slope did not change. Or in this case, our terms that we use instead of slope is stretch or shrink. It didn't reflect because I didn't go from going up left or right to going down. So these are actually parallel lines. So it's this -4 right here that's doing something. And if it is not grouped with x, it actually is moving it down because it's a -4. It moved it down 4. So this is a vertical translation down 4. Okay. Now, if I'm graphing a reflection, if I look at, so the number 5 there, if you look at the equation, it has those absolute value bars, so we know it's going to look like a V. So I know the parent function goes through 0, 0, and it goes up 1, right 1 on the right, goes up 1, left 1 on the left. Okay, there's the parent function. But if I graph this one, this negative out front just means I now reflect that over the x-axis. So it's still going through 0, 0, but instead of going up 1, I'm going to go down 1 and right 1. And I go left 1, down 1, okay? Or down 1, left 1. Sorry, had the order backwards there. And then now we're going to graph a vertical stretch, which meant the number out front is greater than 1. And we treat it like a slope when we're dealing with absolute value and linear, but with absolute value, you just have to remember it is a V. So this has the absolute value bar, so its parent function, oh man, I did not get that straight, sorry. Pretend I'm going through my points exactly. Ooh, tried, okay. And then this one, we'll think of the slope as 2 over 1. So it's going to go up 2, right 1, up 2, right 1, keeps going until it's off my graph. Well, it also goes up 2, left. Okay, so this one See how it's stretched up to the sky more? Okay, like if you stretch your arms get closer together as you stretch up. Okay, so this is a vertical stretch. It's going to get skinnier and farther away from the x-axis. Number 7 here, it is also an absolute value, so it's parent function. Okay. Get the red there. Okay, but this time it is a vertical shrink because this number is now less than 1. So instead of going up 1, right 1 like the parent function, I'm going to go up 1, right 2. And from those points, keep doing that. And you do the same thing going left. Go up 1, left 2. And then you get your little graph. Now this one is a shrink. If you look, it gets squattier. It gets closer to the x-axis. Okay, it's not stretching up, shrinking down to the ground. Okay. Now I realized I was supposed to describe these transformations. So if we go back up to number 5, so this reflected over x-axis. Okay. Number 6, it stretched, is a vertical stretch by factor of 2, because that's that number out front. And then this was a vertical shrink by the factor 1/2. All right, now that you've done these, you should be able to go to the practice and do problems 9, 13, 14, 17, 20, and 25.